standing in the Valles Caldera in the Jemez Mountains of New Mexico. This 14-mile wide caldera is one of the striking features in northern New Mexico. The Valles Caldera is a composite volcanic feature, meaning there were at least two volcanoes that formed in this same location. And the reason that there may have been such volcanism in one area is the juxtaposition of two other major geologic features. These other features include the Rio Grande Rift and the Jemez Lineament. The Rio Grande Rift is a north-south trending feature of extension across southern New Mexico into Colorado, and the Jemez Lineament is a chain of volcanoes that extend from Arizona across New Mexico into Oklahoma. The older caldera in the Jemez Mountains is the Toledo caldera, which erupted around 1.4 million years ago and may have obliterated even older calderas. The younger caldera, which significantly influenced and in fact formed the topography that we see today, is the Valles Caldera, which erupted at 1.1 million years ago. Younger volcanism happened after these two major eruptions, with the eruption of the El Cajete Pumice and the Battleship Rock ignimbrite.
Valles Caldera is the type locality or the best example for resurgent caldera formation. It was here that Smith and Bailey in the 1960s developed a model to explain how calderas like this form. That model has been refined a little bit, but it still stands today. Their model has 6 stages. In the first stage, magma from deep within the earth moves up into the crust. That upward movement of magma causes an extension of the crust and a cracking of the overlying rocks. It also causes a swelling of the overlying rock. So you would see a swelling at the surface and a cracking of the rocks. In the second stage, the actual caldera forming eruption happens. That's when large amounts of magma are getting erupted to the surface through a central vent, and they will produce a very large volcanic plume that's composed of ash and pyroclastic material and will extend 20 to 30 miles into the sky. Eventually, that plume will collapse and form pyroclastic flows. These pyroclastic flows will form deposits that are hundreds or 200 meters thick in places. And those we can see all over this type of calderas. In the third stage, and that's the important stage at caldera formation, that's when the caldera collapses into the magma chamber. So the magma chamber has been partially emptied because of the eruption, and that causes the rock above the magma chamber now to collapse into that magma chamber. This causes a big hole in the ground, 20 to 30 kilometers in diameter. In the fourth stage, this hole gets filled by sedimentation and perhaps by formation of a caldera lake that can exist for many thousands of years. During that fourth stage, we also have some small amounts of volcanism. In the fifth stage, that's also a very important stage, the resurgence of the caldera happens. So the magma that's still in the ground, that hasn't been erupted yet, is still moving around. It has still some activity. It's trying to move to the surface. And that causes the overlying rock to again spread out, extend, and swell. And it's pushing up significant amounts of rocks, producing resurgent domes, which we see, for example, at the Redondo Peak. And then the sixth stage and the final stage is when the resurgence continues, but you also get additional volcanism, small dome eruptions, very viscous magma that's completely degassed now are erupting through these cracks and fissures into the lake that was there possibly. During those eruptions, you get also some mild explosive eruptions, but it's nothing compared to the initial caldera forming eruption. So at the Valles Caldera, we have all of these 6 stages present. We can see it in the geological record, we can see it in the field, and the eruption happened, the big eruption happened about 1.2 million years ago, but the activity has continued till about 30,000 years ago.
Thanks to their bowl-like shape, calderas often form lakes within their collapse centers. One modern example of a caldera lake is Crater Lake in Oregon. The Valles Caldera has hosted several lakes since its formation. A careful inspection of the landscape reveals ancient shorelines that we can see in the modern topography. Scientists have used drill cores of these lake sediments to help unravel the climate history of northern New Mexico and the Southwest. Hot springs and geothermal processes attest to the ongoing magmatic activity in the area. In some instances, the crater rim would fail, causing an almost instantaneous draining of the Caldera Lake. This would lead to catastrophic megafloods, which helped erode the striking canyon topography we see around the Pajarito Plateau.